Parametric curves, video number 9. Draw the curve given parametrically by x equal t square, y equal 2 minus t square. First, for sure, we should know something very important. Since x is equal to t square, then what? Then x is greater or equal to 0. Since it is squaring number, squaring parametric number, then it should be greater or equal to 0. First, what is the domain according to t? The domain of this function is from minus infinity to plus infinity. According to t, the domain is from minus infinity to plus infinity. All right. We start by limits. After the domain, we start finding some limits. Limit at the borders of the domain, right? So as t approaches negative infinity, we need to find this limit for x in terms of t, right? And y in terms of t. If we substitute infinity instead of negative infinity instead of t, x equal t squared, so it should be plus infinity, and limit of y of t as t approaches negative infinity is equal to this one. T squared is negative infinity squared positive infinity times minus, so it should be negative infinity plus 2 negative infinity. And what's that mean? This means simply, if we want to draw this function, y-axis, x-axis, right? As x approaches positive infinity, here is positive infinity, y approaches negative infinity for t approaches negative infinity. So it's somewhere as x approaches positive infinity, y negative infinity, x positive infinity, and y negative infinity, right? So it's somewhere in the south east corner, for t is negative infinity. This is very important. We will see how exactly later. Now, the limit for t approaches plus infinity of x of t is going to be also plus infinity, and limit of y of t as t approaches plus infinity is going to be minus infinity, right? Minus infinity. Same, because t squared will not change anything, right? So the same. So since the same, plus infinity for x, minus infinity for y, so we will end when t approaches plus infinity in the southeast corner also. So it starts somewhere in the southeast and ends in the southeast corner. After that, we find the derivative, which is y prime. Y prime is equal to y dot to x dot, right? So instead, first we have to find x dot, and we all know that x dot is the derivative of x. It's the x in terms of the parameter t. So what is the derivative of x? It's 2t, right? And what is y dot? It's the derivative of y to dt. So it's minus 2t. Derivative of 2, 0. Derivative of minus t squared is minus 2t. This means that y prime is equal to y dot to x dot, right? Which is equal minus 2t over 2t. We simplify t, the answer is going to be minus 1, which is strictly negative, but under condition that t should not equal to 0, because we simplified t already. That's great. Let's continue. At t equals 0, y prime is not defined, right? Because t should not equal to 0, because it's in the denominator of y prime before the simplification. So y prime is not defined at this t equal to 0. Otherwise, if t not 0, the curve is strictly negative. So the slope is increasing, right? The function is decreasing. How can we do that? First, let me find the points of intersection. If right? T equal 0. This means that, or let me start with x, right? If x equals 0, when x equals 0, x is equal to t squared. This means t squared equals 0. In this case, that t is equal to 0. And if we substitute t equals 0 and y equal 2 minus t squared, so y will be equal to 2. So for t equals 0, we have point 0 abscissa to ordinate. Let me go to the function. 0 abscissa to ordinate. Let's say 1, 2. This 2 ordinate is for t equal 0. Another special point, if y equals 0, this implies 2 minus t squared equals 0. This means that t squared equals 2. This means t is either plus or minus radical 2. In this case, if t squared equals 2, then x is equal to 0. So abscissa 0 and ordinate 0, abscissa 0, ordinate 0, so no, x not equal to 0. If t squared equal 2 and x equal t squared, so x is equal to t squared, which is equal to 2. So x is equal to 2 and y is equal to 0 for t squared equal 2, or for t is plus or minus radical 2. Let's go back. We have a new point now, abscissa 2, ordinate 0, for which point? For t equal plus or minus radical 2. That's great. And we know that we don't have any function over here to the side of ox prime. Why? Why? Because we don't have x negative. X is equal to t squared, so always should be positive. That's why what we said in the beginning, right? So my curve is going to be exactly this curve, and at the end of this southeast corner, this is for t equal minus infinity, and for t equal not equal approaches minus infinity, t approaches plus infinity as well, right? We can do it in another way. We can say, right, we can say since x equal t squared and y equal 2 minus x 2 minus t squared, right? This implies y equal 2 minus x. Instead of t squared, I replace x. So we have equation of straight line, but under condition that x should be greater or equal to 0. If we do the points of variation, table of variation of this straight line to draw it, right? If x is 0, y is 2. If y is 0, x is 2. So we have same points here, 0, 2, 2, 0, 0, 2, and 2, 0 this point, and 0 to this point, right? For x negative is rejected, so x should be greater or equal to 0, and we join these 2 points to have this equation of straight line. So this straight line is exactly y equal 2 minus x for x greater or equal to 0. Right?